Welcome to This Explainer. Look, today we're exploring the absolute frontier of human recovery. We aren't just talking about, trying to feel a little less groggy tomorrow morning. We are talking about the heavy hitters: mitochondrial energetics, neuroplasticity, immune regulation, and literally your overall lifespan. So, let's dive right into the invisible forces that are actively shaping your brain and body every single night.
Let's start by challenging a pretty massive assumption. Most of us just think of the bedroom as this passive, empty box. It's just the room we happen to power down in, right? Well, the science reveals something entirely different. Your bedroom is actually a highly active biological interface. It's an ecosystem, and it is continuously sending signals to your autonomic nervous system, either pushing you down to deep, restorative parasympathetic recovery or keeping you trapped in a low-grade sympathetic fight-or-flight state.
To really get our heads around this, scientists use a fascinating academic framework called socio-environmental somnology. Basically, this looks at how your physical surroundings dictate the very architecture of your sleep. And the absolute most intimate layer of this environment? It's something called the sleep microclimate. That's the actual air trapped right there between your skin and your bed sheets. That tiny space has its own completely distinct temperature and humidity, and believe it or not, it's actively manipulating your endocrine system and your cardiovascular function the entire time you're lying in bed.
Which brings us to part 1, the biological thermal engine.
Now, just to simply initiate sleep, your core body temperature has to drop by about 1 to 2 degrees Fahrenheit. What happens is, your body rushes blood flow out to your hands and feet to dump heat, and about 2 hours in, you hit your peak temperature decline. Now this drop, it's a biological non-negotiable. It is the exact trigger that plunges you into slow-wave deep sleep. And that's crucial, because that is when the glymphatic system kicks in to physically wash away the neurotoxic waste that's built up in your brain all day. If you don't get that thermal drop, that deep cellular power wash simply doesn't happen.
But this whole thermodynamic actually exposes a pretty terrifying biological vulnerability. See, slow-wave deep sleep absolutely thrives in a cool room, right around 60 to 67 degrees Fahrenheit. But then, consider REM sleep. That's the stage responsible for your emotional resilience and your memory consolidation. During REM, your body completely suspends its ability to thermoregulate. You literally stop sweating and you stop shivering. For all intents and purposes, you become cold-blooded or ectothermic. Your brain is suddenly relying entirely on the room's ambient temperature to survive and recover. If that room gets too hot, your brain will literally abort REM sleep just to protect your core organs.
So the takeaway here seems obvious, right? You want it cold. But hold on, because there's a serious tipping point. If you drop the room below 54 degrees Fahrenheit, it totally backfires on your biology. At that extreme, your body detects a threat to its core temperature, and it is forced to divert precious metabolic energy just to keep you warm. This creates a sympathetic stress response that will abruptly compress your deep sleep. What we're really looking for here is thermoneutrality. That's the sweet spot where your body has to spend zero energy trying to heat or cool itself. And that brings us to the actual fabric you're sleeping under. The materials in your bed are a huge part of that sleep microclimate ecosystem we just talked about. Synthetic fabrics, things like polyester and microfiber, they basically act like plastic wrap. They trap heat and can raise your local body temperature by 1 to 3 degrees Fahrenheit. And honestly, that is more than enough to completely derail that crucial core temperature drop we need. Now, if you sleep with a partner and one of you runs hot while the other runs cold, the science actually suggests dual fabric layering, using highly breathable percale or linen for the warmer sleeper and maybe a sateen for the cooler sleeper. It's all about engineering the perfect individual microclimate.
Okay, moving right along to part 2, the neurotoxicity of bedroom air.
The mechanisms hiding in the air we breathe at night are genuinely fascinating, but also kind of alarming. We all know air pollution is bad for our lungs, sure. But recent studies show that microscopic particulate matter, specifically PM 2.5, can be inhaled and literally travel right up your olfactory nerve. It completely bypasses the blood-brain barrier and goes straight into your central nervous system. Once it's in there, it triggers neuroinflammation and a systemic fight-or-flight response. Your body basically senses an invader and completely overrides your parasympathetic recovery, which leaves you with that fragmented, super unrefreshing sleep.
And it's not just particulates floating around. It's literally the air you're exhaling. When you shut your bedroom door and close the windows, carbon dioxide levels absolutely spike. A really interesting study from the Technical University of Denmark showed that when bedroom CO2 hits 3,000 parts per million, which honestly happens pretty easily in a sealed room, overall sleep quality scores drop to just 80.8%. That's compared to a well-ventilated room sitting comfortably at 800 parts per million. That high CO2 linearly decreases your slow-wave deep sleep and completely tanks your cognitive performance the very next day.
Now, whenever we start talking about air quality, I always get this exact same question. Well, can't I just put some nice houseplants in my bedroom to purify the air? It's time to pivot for a second and debunk a massive biological misconception. We really need to look at the famous 1989 NASA houseplant study because it birthed an absolute internet myth. When NASA actually tested plants for removing airborne chemicals like benzene, they found something shocking. A plant with leaves removed 58% of the chemical in a tiny, sealed chamber. But get this, a plant with all of its leaves completely cut off still removed 50%. Even just a pot of fresh soil with no plant in it at all removed 20%. The truth is, the soil microbes are the ones doing the heavy lifting, not the leaves. To actually purify the air in a standard-sized bedroom, you wouldn't just need 1 or 2 cute plants, you would need roughly 25 to 50 large plants to even make a noticeable dent. For healthy sleep air, you really need mechanical ventilation and HEPA filtration, not a fern.
Let's transition to part 3, light, clutter, and cortisol.
Let's walk through the actual cellular cascade here. When you're staring at a smartphone or an LED screen at night, you are blasting your eyes with short-wavelength blue light, specifically peaking right around 480 nanometers. Deep inside your retina, you have these specialized receptors called IPRGCs. Now, they don't process vision. Their sole job is to detect the time of day. When they catch that 480 nanometer light, they fire a signal straight back to the suprachiasmatic nucleus, which is your master biological clock. This immediately tells your pineal gland to totally halt melatonin production. Just 2 hours of evening screen time directly suppresses your melatonin and causes a massive 1.1 hour circadian phase delay. You are literally jet-lagging your own brain from the comfort of your bed.
But honestly, it's not just the light in your room, it's the physical objects around you. Visual bedroom clutter, the piles of laundry, stacks of unread mail, that messy desk in the corner, that actually acts as a persistent environmental stressor. Your brain's visual cortex is constantly processing all that disorganization in the background. This subtly taxes your cognitive capacity and triggers your HPA axis, which kicks off a low-grade fight or flight response. You just cannot achieve deep, restorative relaxation when your brain is subconsciously scanning an environment it interprets as chaotic and demanding of future effort.
This clutter is quite literally altering your biochemistry. A healthy cortisol arc should look like this: a big waking surge in the morning, a steady decline throughout the day, and a deep evening low point. That low point is a strict biochemical prerequisite for your melatonin to be released. But when visual clutter keeps your stress response active, it chemically blocks that evening melatonin surge. You end up lying there in bed, feeling entirely tired but wired, simply because your room is messy.
Which leads us to our final section, Part 4, Engineering the Ideal Microclimate.
So what does this all mean for you tonight? Well, here is your premium longevity protocol for engineering the ultimate bedroom ecosystem. Step 1. You want to target an ambient room temperature of 60 to 67 degrees Fahrenheit and exclusively use breathable, natural fabrics on your bed to support that crucial core temperature drop. Step 2. Run a HEPA purifier to capture that PM 2.5 and keep a door or window at least slightly cracked to maintain low CO2 and prevent systemic inflammation. Step 3. Absolutely block all 480 nanometer blue light in the hours just before bed so you can protect your natural melatonin surge. And Step 4. Clear your visual field of clutter. Give your brain a break so your cortisol can naturally bottom out. I want to leave you with one final, provocative thought. Your health span, your emotional resilience, and your entire cognitive performance tomorrow are being dictated by the physics and the chemistry of your bedroom tonight. Take a good look around your sleep space this evening and ask yourself, is this room a sanctuary engineered for biological recovery, or is it a hidden source of systemic stress? The science is abundantly clear here, and the power to optimize your nervous system is literally resting right in your hands. Thank you so much for joining me on this explainer, and I highly encourage you to start redesigning your microclimate tonight.